So this lesson is going to look at sequences and series word problems. So everything you've learned before with a cute story attached, I have all the confidence in the world that you guys can handle this, and this is going to be nice. A pile of logs has 24 logs on the bottom layer. So sometimes when I'm reading these, I like to list the terms so that I can see the sequence. 24 logs, and then the next layer has 23 logs, and then 22 logs. Okay, I get the idea, and so on. Blah, 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 blah. The top layer, okay, that's going to be the last one, has 10 logs. Okay, so whenever you do this, please make the sequence, and then ask yourself those magic questions. The first question I'm going to ask is this arithmetic or geometric? Arithmetic it is. What's the d value? Since they're going down, -1. So this is a sub 1 the first term, a sub 2 the second term, a sub 3, and this is a sub, oh, I don't know. I'll call it a sub n. So it seems like I'm going to have to do some a sub n work. Since it's arithmetic, I'll make a formula. First term's 24 plus n minus 1 times d, which is -1. Great use of those parentheses, people. The formula for a sub n is -n plus 25. And I'm going to use this formula and plug a 10 into it. So if you put 10 into that formula, it seems like n might be equal to 15. Okay, now I know that this is the 15th term. Okay, let's read this question again so I answer the correct one. Find the total number of logs in the pile. So this is a sum problem. Is it finite or infinite? Since it ends, it's finite. So you have to tell me how many terms are you adding. Since there's 15, we're going to sum 15. So we're going to use the correct formula. Please pause the video, actually try this, use the correct one, get an answer with some units, and I'll see you in a second. Come on, don't be a lazy butt, type it in. It comes out real nice. None of these are decimal answers. How many logs? There's 255 logs in the pile. Okay, I'm going to put a red star by this next one because I've seen so many people, usually 30% of the people get this wrong. And this is a really easy question if you make the sequence. So it says, find the sum. Okay, I'll do that. Integer multiples of 6. Okay, it doesn't say powers, it says multiples. Multiples means times by 1, times by 2, times by 3. So 6. 6 times 2 is 12. 6 times 3 is 18. So I know we have to multiply to make the multiples. And it goes all the way to 600. Okay. Is this arithmetic or geometric? No, now look closely. Look at the terms. I know how we made them, but each term has 6 more. This is arithmetic, guys. Arithmetic. And since it's arithmetic, the d value is going to be 6. A lot of times people rush through this problem and they say it's geometric, but be careful. Red star. Okay, find the sum. So when I'm looking at these terms, I know this is the first one, and I know this is the second one, and I know this is the third one. And this is the, well, maybe you can just think about it. A sub 1 is 6. A sub 2 is 12, because 2 times 6 and 3 times 6, and this must be the, yeah, it's the 100th term. If you don't know that, you could use this process that we did up here to find it officially, but I think that that's pretty straightforward. So I'm going to say that that's the 100th term, and we are going to find the sum of 100 arithmetic terms. So please find the sum. It's going to be nice. And the answer is 30,300. There's no units here, so we'll just say that. Okay. What else do we have? Oh, money. You've just been hired at an annual salary of 18,000. Okay. But you expect to receive some annual increases. So what I would like to do is maybe write down the first couple salaries. So the first year you make a measly 18,000. But you're going to get an increase of 5%. So how do we calculate your salary? If we take 18,000 and times it by 0.05, 900. Is next year's salary 900? No, of course not. It's 18,000 plus 900. So the next year's salary is going to be 18,900. Okay, and we can keep going with that process. So this is definitely geometric since we're multiplying. And the R value between the terms is not 0.05. If you want to find an R value, you could always do it manually by doing 18,900 and divide by the previous one, and we get 1.05. 1 standing for 100% of this, plus an additional 5. So every time you multiply by 1.05, you're making that money plus a little bit more money. If you multiplied by 100, you get the same thing. So R is 1.05. Okay, what will your salary be when you begin your 5th year? So here's the first year, the second year, the third year, the fourth year. The 5th year would be considered A sub 5. So we're going to calculate A sub 5. A geometric term is A1 times R to the power of 1 less, n minus 1, 4. So how much money are we going to make? 18,000 times 1.05 to the power of 4. I'm going to chop off that so it sounds nice with money. So let's use the approximate equal to. And it's approximately $21,879.11. Still nothing to get excited about. I would probably study more math and get a better paying job. Okay. A contest will have 5 cash prizes. Okay. 1, 2, 3, 4, 5 cash prizes, totaling $5,000. So which winner gets 5,000? Oh, none of them get 5,000. Together, that's 5,000. Okay. There's going to be a $100 difference between the successive prizes. Okay, so that means D is negative 100. There's a $100 difference. I guess this problem could be done another way too by saying it's a positive 100. So I don't know. When you say A sub 1, is that the first prize and that's the most amount of money? 1, 2, 3, 4, 5? Or are you going to say that 1, 2, 3, 4, 5? It doesn't matter because the 5 numbers are going to be the same numbers. Okay, so I'm going to say the first place gets the biggest and then they go down. Okay. So the sum of those 5,000, the sum of those 5 is $5,000. So it seems like we might have to do a sum formula. Okay, S sub 5. Since it's arithmetic, let's see, the calculation would be 5. A sub 1 plus A sub 5 all over 2. And I know the sum is 5,000, so we can go ahead and put 5,000 in there. A sub 1 plus A sub 5. And I could definitely multiply by 2 and divide by 5. So that makes 2,000 equals A sub 1 plus A sub 5. Now I certainly cannot calculate like this. I have too many variables. I have too many variables, and so I'm going to have to replace one of them. I think what we're going to have to do is some work here with a sub 5. Can you write a formula for a sub 5? A sub 5 is a1, which I don't know, plus 4d. Oh, wait, we know d. d is negative 100. So a sub 5 is a1 minus 400. Okay, if I put that expression into the equation I'm currently working with, I'll have all the same variable. 2000 equals a1 plus a1 minus 400. So a sub 1 is $1,200. So let's go up to these prizes because I was supposed to find the value of the first cash prize. I'm going to find all of them. So I don't know if that means the first place one. A sub 1 is $1,200, and they're going down by 100, so that means $1,100. $1,000 is still a good prize. $900 and $800. And just to make sure I'm going to get that A, do all of these add up to 5,000? 1,000 here, 2,000, and 2,000 definitely makes $5,000. If I'm not clear on a test, you could always ask me what I'm asking for, or just list all of them, and then you'll be sure to have it. Okay, this last example here has some more sum formulas mixed in. The sum of a series is 530. Okay, it says a sub 1, and it says d. So now I know at least we have arithmetic. I like to make a list of all my data. So I know a sub 1 is negative 2. I know d is 3. And I guess if you're really confused with a lot of these problems, then I would suggest you just write out as many formulas pertaining to arithmetic as you can, and then you're bound to at least get somewhere with them. So I know that the a sub n formula for arithmetic is a1 plus n minus 1 times d. So I guess I can generate an a sub n formula here. 3n minus 5. Okay, that might come in handy. The other thing they say here is the sum of a series is 530. Okay, find the number of terms. That means this sum is finite. We cannot add an infinite sum, but I still don't know how many terms. So that means that the sum of n that I don't know, the sum is 530. I'm thinking maybe I should write a sum formula, see where that takes me. So let's see. Arithmetically speaking, S sub n is n times a sub 1 plus a sub n all over 2. Since we know the sum is 530, let's plug that in right there. Do we know n? No, we don't know. That's what we're trying to find. Find the number of terms. That's n. Okay, so I don't know that. Do I know a sub 1? Yes, let's plug negative 2 in. A sub n is the last term, but I have a formula for that I cleaned up nicely, so maybe I'll use that. 3n minus 5 all over 2. Well, I'm noticing that the only letter I'm missing is n, and that's exactly what I wanted to find. So let's multiply by 2, make 1060 equals, maybe we'll clean this up here a little bit. This is going to be negative 2n plus 3n squared minus 5n. Distribute that in. A quadratic. To solve a quadratic, you got everything on one side. I'm going to put everything on the right. In descending order, 3n squared minus 7n minus 1060. Hey, don't we have a program to solve quadratics called the Quadratic Formula program? Let's just use that. So we're going to use our quadratic formula program, and 3, -7, and -1060. So n, the number of terms, is 20. Oh, 2 answers. Or -53/3. Well, wait a minute. I agree that there could be 20 terms. Could there be a negative number of terms, or even a fractional amount of terms, like there's a term and a half, like half of the term? Absolutely not. So the only answer that makes sense here is 20 terms. Good job.